Alrighty guys, so we already pulled the bolts out. This back bulkhead, this mount, 1, 2, 3, boom, boom, boom. This comes off. We'll get rid of the stabilizing brace in a minute, but I want to show you the S&P mount. This is the orientation for this side, right? It's going just like this. Now I thought this was a cool feature. Other people had complained about it hitting the housing on the sensor. S&P notches the mount. It's pretty cool. Clears the sensor just like so. Pretty cool setup. I don't know if you can see them in the shadow, but there, give you a little bit better look. It's a really cool product. Alrighty guys, so it's cold, it's rainy, but we're still moving ahead on the TDI swap. So a couple things we're gonna do. One of them is we're gonna do an EGR delete. So we're gonna get rid of the EGR, and that's gonna clean up a lot for us. It's gonna clean up this whole crossover. This is all gonna get removed. And now we've reduced our chances of the EGR system leaking and basically burning up coolant. So that'll be a good thing for us to delete. If anything, from what I've read, should give us a little bit improvement in performance just by deleting the EGR. Another thing too, talk to the customer. This core support's really hammered. I mean, you can see it's been hit, it's got cracking Bondo. We de-ate it a little bit, but it's basically a sculpture. You can also see down in like this corner right here, the best way I can describe that is some booger welding. Basically, this thing took a whack right here. So after talking to the customer, we're gonna make this thing a little more racy. We're gonna do a fabricated core support. We're also gonna do hood pins. Customer said he's had issues with the hood release and the cable. He's kind of the same mindset I am, the KISS principle, keep it simple, stupid. So rather than messing around with the hood cable and everything, we're just gonna clean it up, get rid of the cable, get rid of this latch system, get rid of all that up there. We're just gonna run 2 simple pins. So the main thing we're gonna be doing today is, now that I got the motor mocked up, before I mock up the intercooler and radiator combo, and before we start plumbing all of our exhaust and turbocharger ducting, we're going to start designing and fabricating a new core support. So one of the first things we're going to have to do, obviously, we're going to cut out these bad welds. Like I said, most of this car is glued together. So we're going to break this all loose. Obviously, the supports for our headlight buckets, we're going to integrate those into the new piece. But for the most part today, we're just going to be measuring for a new core support, designing it in SolidWorks so we can mount our radiator intercooler combo. Pretty nice deal from S&P. I like that it comes all wrapped up. That was a nice touch, so the pins on the core don't get bent. But yeah, this is a nice looking unit. It's gonna go in like this. You have your, for lack of a better term, I'll say your intercooler side here, and your engine coolant side on what would be the driver's side. So this is the orientation of the intercooler radiator combo. Obviously sits in the car. But we want to get all this done, get the intercooler mounted, finalize this front section so we can start fabricating the rest. And yeah, in the next one, I'm going to show you guys how we measure and draw for this. Alrighty guys, so you can see here's our old beat up ugly ass core support. Once we took it out, you can see it's had some other repairs before. So it's probably a good thing we're just scrapping this completely. It's seen better days, pretty beat up. Now given that, what we did while we were doing everything and cutting it out is I took a couple measurements. Inside to inside on the inner structure, of the subframe, or the monocoque as you want to call it, it's 48 1/4. Add to that, we've got about a 1/2 inch of crown on this core support. Now earlier we mounted the hood. We're going to be going back and forth and checking as we're measuring for things. Hood clearance, like I said, we're switching the hood pins. So preemptive strike, we took the hood latch out, it's unneeded, and we're going to clean up the whole bottom of the hood. Like I said, the car's been painted too many times to count. So we're going to make that look good, probably spray it back to body color. As far as this core support goes, you can see the braces that also are for the headlight bucket attachment. We're going to be making fresh ones. We're going to draw everything in SolidWorks and have it all CNC formed. And we're going to do something nice with this core support. Make it a little bit easier to look at, nicer to look at, and do some really nice integrated mounts for the intercooler radiator combo from S&P. And yeah, just by ditching this core support, it's really just going to improve the overall look of the project. Alrighty guys, so like I said from our previous video, we got our measurements. So right now what I'm going to do, I don't know if any of you guys have used SolidWorks. It's probably the same on SketchUp or Fusion 360 or anything like that, but let me show you what I did. So I like to draw how I'm looking at stuff. So let's start on the top plane. Let's do a sketch. I like to make my origin about the center. And we know our overall width is going to be 48 1/4. Because this is a midpoint line, it's going to automatically center it for us. Now what I want to do is I'm actually going to make this for construction. I want to keep that a dotted line. Now as far as how wide we're going to make the core support, we're going to do 2.5 inches. But here's the reason why I wanted to set this center line at 48 1/4. We talked about how this core support has about a 1/2 inch crown. So I'm going to put that in there just like that, right? Now we've got a reference point for that 1/2 inch. Now what I like to do for arcs like this, I'm going to do a 3-point arc. We're going to make it coincident with this point right here, and boom, we've got a nice gentle arc. Now as far as the drawing the back of it, we want the core support to be 2.5 inches deep when viewed from the top. So here you see I've set it to 2.5, 2.5, and here we go. Now you'll notice when you do offset lines like this or offset radiuses, the radius doesn't continue. To fix that, we can add another construction line and make it coincident. Same thing over here. We'll draw another construction line, vertical, right? And we will make this coincident as well. Now, once we have that, you'll see your lines have gone from blue to black, which is good. So what I'll do right here is I snap those a little long. I'm going to trim and trim. Next, what I'll do is I'll take this construction line and this construction line, and they will not be for construction. Boom. Now you can see we have the top of our core support. It's all grayed out, which means now our drawing is fully defined or constrained. It loops all the way around. So because this is a sheet metal part, I'm going to use the sheet metal function. And we're going to start with the base flange tab. Now I'm going to be making this out of mild steel. And we're going to go a little thicker. We're going to use 10 gauge, and here's why. This piece is going to be slightly skeletonized or lightened up. We're basically going to be strategically moving material from it, not only to make it look good, but to also save some weight. You don't want the ugliness of just a big piece of plate running all the way across. You want the strength, but we also want to make it visually appealing. So we're going to make this out of 10 gauge steel, which is 0.135 inches. And boom, here you go. So now we've got the top of our core support. Now, as far as making a flange or a lip on this core support, obviously when you have a bend along a radius, it can't be done in a traditional press brake or finger brake or anything like that. So what we're actually going to be doing on this is we're going to be calculating the actual length and then making an additional piece that we're going to weld from the inside. And there's a lot of ways to form it. We can slip roll it, we can heat it and bend it. There's all kinds of ways. So let's do this. Let's make a new core support folder. Oops, sorry, didn't need that registry. Okay, so now that we got this, let's save it. Super simple, right? We're just gonna call this one top. Okay, so now we got the top of our core support. So let's make an assembly out of it. All right, so you'll see here in SolidWorks, yes, it gives you the radius, but you look over here in your measurement table, it'll give you the arc length, which is 48.253, a little bit more than 48.25, not much more. So this is what I'll do if I'm drawing a sheet metal part like this in SolidWorks. I'm gonna start a new part. I'm gonna do a top sketch. I'll make my datum from the far left, and I'll repeat the process. We'll go 48.25 for the overall width. And I'll come in here, find my center mark. And we'll make this 0.5. Now I'll come back through with my 3-point arc sketch tool. Once I have my sketch, we're going to make this line and this point, we're going to make them coincident. We want them to run into each other. Now, the way you saw me use the sheet metal tool before is not the only way the sheet metal tool can be used in SolidWorks. So, once we have this on this arc length, right? Believe it or not, this single sketch can be used to create a sheet metal part. So you'll see off of this base flange tab right here, you see where that line is? It's basically going to allow me to make a sheet metal part just off that one line. So if you see the direction, it says it's extruding from, right? Direction 1. This is allowing us to go, quote, up and down, right? If anything, it should have been drawn on the other plane, but there's a tricky way around this. So if we say our sheet metal parameters are 0.135, that's fine. If we go to direction 2, as far as where it's saying to what length it wants to be extruded to, I want to make this lip about a 1/2 inch, okay, 1/4 in each direction. So once I have that, you'll also notice it's saying our material thickness, right, is 0.135, the same 10 gauge material we talked about. So If I close this, boom, there's our next sheet metal piece. Super simple. Let's just say this front. All right, so if I go back into my assembly, see, now my core support's starting to take shape. Now, ideally, if we were, you know, Volkswagen itself, we would be stamping these parts, but they're not going to be stamped. They're going to be fabricated. So for the manufacturing process on this, we're going to weld it from the inside, and then we're going to metal finish it. So as this core support starts coming together in SolidWorks, there you go, you'll see. Now you got your curved front lip on the core support. As it starts coming together in SolidWorks, I won't hold you guys on this video all the way through it, but in a little bit you're going to see the end product and exactly how we design not only the core support but all the attachment features as well.